Hello out there, welcome to this tutorial on quadratic equations. In this video, we'll be looking at expressing a quadratic equation as complete or vertex form. So this is part 2 of this tutorial. If you are joining us now, check the description section of this video on our YouTube channel to get the link to the first part. So we start with the problem. So problem 1. Given that 2x squared minus 6x plus 19 is equal to a into x plus b all squared plus c, find the numerical values a, b, and c. So we start the solution of the problem. We have a 3x squared minus 6x plus 19. We're going to keep this constant value and concentrate on these algebraic terms. So what we do is we are going to factor out 3 since the coefficient of x squared is 3, which makes it different from the first part of this tutorial. And the first part, the coefficient of x squared is 1. So factoring out 3, we'll be left with x squared minus 2x in the bracket, then plus our 19. So if you expand this, you get the first two parts. So what we'll do now is to now express it as a perfect square, that is x plus b squared in that form. Still maintaining our 3, we have our bracket x plus something or minus something squared. And what goes inside this bracket with x is we pick the coefficient of x, which is negative 2. We divide it by 2, and that gives negative 1. The division of the coefficient of x by 2 is the method. So you always divide by 2, and that will give us negative 1 inside the bracket, then plus this 19. Meanwhile, we are meant to square this and subtract it from 19. Since the coefficient of x squared here is 3, which is outside this bracket, what we'll do is we square negative 1, which is 1. We then multiply by this 3, and that will give us 3. We then subtract the 3 from 19. So I repeat again, the constant value we have inside this bracket is squared. We then multiply by this 3, giving us 3. We now subtract it from 19. So our final answer is going to be 3 into x minus 1 all squared plus 16. So we have expressed the quadratic equation in the form a into x plus b all squared plus c, where our a is 3, our b is negative 1, and our c is 16. And that's all for the solution of problem 1. We then go to problem 2. For problem 2, express 11 minus 8x minus 2x squared in complete or vertex form. So the complete form was what we saw in problem 1. In our solution, we are going to rearrange it in standard form. So I'm going to rearrange this in standard form so that I have the term with x squared, x, and the constant term coming last. So I have negative 2x squared minus 8x plus 11. Like we did in the first problem, we factor out the negative 2. So we have negative 2 into x squared plus 4x, then plus 11. If you expand this now, we are going to have this back. We then express this bracket as perfect square. So we still have our negative 2 outside, x plus something squared. And what goes inside the bracket is pick the coefficient of x, which is plus 4, divide it by 2, and that is plus 2. So we have the plus 2 here. Remember, I told you dividing the coefficient of x by 2 before placing it together with x in the bracket is the method. you always divide by 2, whether it is divisible by 2 or not. We have a similar problem of the coefficient of x not divisible by 2 in part 1. So we've done that. We still have our plus 11. Then the next thing is something must be subtracted from this 11. What is that? Is to take this constant inside the bracket, square it. When we square it, we are going to have 4. Then we now multiply by what we have outside the bracket here, which is -2. That's going to give us -8. We subtract it from 11. So 11 minus the -8 we obtain from here. Simplifying this, our final result will be -2 into x plus 2 all squared, then plus 19. This is negative negative giving us positive. 11 plus 8 gives 19. That's the end of solution to problem 2, as we have expressed the quadratic equation as complete or vertex form. And this is the highest we can take in this tutorial. Thank you for watching. I hope you enjoyed it. Remember to check the description section of this video on our YouTube channel to get the link to the first part of this tutorial. Until we come your way again, goodbye.